All right, so we're going to look at how to add radical expressions when the radicands are not the same. All right, when the radicands are not the same. So in order to do that, we first need to know what our perfect squares are. So I went ahead and wrote over to the right the first few perfect squares and their factors. So if you look, we have 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and so forth. So a perfect square is basically where you have two numbers that are the same and you multiply them together to get another number. So squared is when you have two of something. So that's how we got those numbers. So in order to simplify an expression, a radical expression with different radicands, we have to first simplify each individual radican. So I'm going to go ahead and simplify 18. We're going to keep the house, and I like to draw arrows down to show you the process. So what I like to do is look at the number 18 and then look at your perfect squares to see which one of your perfect squares go into that number evenly. So if we look at 18, the largest number that goes into 18 evenly out of our perfect square list is 9. And then we have 9 times 2 is what gives us 18. And then we can go further and say, well, what gives us 9? So look over at our little table, and 3 times 3 gives us 9. Okay. All right. So now, in terms of how we continue to simplify that, when you get a pair is two numbers that are the same. I like to circle the pair and say that this is a pair. We only need one representative to go outside. And then whatever is left over stays on the inside. So now we have 3 times the square root of 2, which would be the most simple form of the square root of 18. 3 times the square root of 2. And we're going to do this for each one. So now let's look at the square root of 8. What is the largest number from our perfect square list that goes into 8? We have 4. 4 times 2 gives us 8. And then what gives us 4? If you look at our chart or table, we know that 2 times 2 gives us 4. And then we bring down our additional 2 that was already there. Now we are going to look for pairs. We have a pair here. And we're going to take one of those pairs. I like to mark them out, put it outside of the house, and then the number that's left over stays inside. Okay. That's so 2 times the square root of 2 is the most simple version of the square root of 8. And then lastly, let's do the square root of 32. We're going to do the same thing. Look and see what is the largest number out of our perfect square table that goes into 32 evenly. So 16. 16 times 2 is 32. Now, how do we get 16? So if you look at our table again, I have 4 times 4 is what gives me 16. And then I bring down my times 2. Now, 4 times 4, we could break that down even more, but 4 times 4 is a pair. So let's go ahead and put 4 on the outside of our house and bring down the 2. Now we have the same index. We have the same radicand. And all we have to do now is add the coefficient 3, 2, and 4. So 3 plus 2 is 6. 6 plus 4. I'm sorry, 3 plus 2 is 5. I don't know why I said 6. 3 plus 2 is 5, and 5 plus 4 is 9. And then we put our square root of 2 inside of our house, and that is our final answer. Please make sure you double check your work because you see how I easily added incorrectly. So 3 plus 2 is 5. 5 plus 4 is 9. And then we bring our radicand down. So we have 9 times the square root of 2.